Second episode of building a todoMVC application with Rust as a backend and native web components on the frontend. In the last episode, we created our model layer, which is our data layer, with a to-do model access controller, with our CRUD APIs, using SQLB as a SQL builder, and SQLX as our database executor. We use PostgreSQL in a Docker. So here, for example, we can go to our database terminal, run the Docker for the SQL, and then when we go to the backend, we can do our magic cargo watch, and that will run all of the 7 tests. Everything is created via these SQLs. We recreate the database at every save. We create the schema, to do, very simple, and we see the database with some test data. And then we have our test files, which have been remapped here into our underscore test with these best practices to make sure that we have everything clean and in their own files. So the first thing we're going to do is to create our web layer. So for that, we're going to save our first HTML file, which is going to be our index.html. So we go to the front end, we create a file, which will be index.html into our web folder directory. We're doing a very simple HTML file, hello world todoMVC, with just a title and an empty icon. So now what we want is to go to the server, to the localhost 8080, for example, and get this file. So the way we're going to do that, we're going to close those files, and we're going to go to our web layer, our module. So the way we're going to design our code here is to have a pub async function, which will be start web. And that will be called by the main function. We'll have the web folder. That will give us flexibility. We'll see that later. Reference of string, a web port, U16 plenty enough, and our database, because that will be passed into our filters, and we're going to make it arc of DB, which is our database object. And that will return result void, because it will actually run infinitely, and an error that we're going to define right now. To make sure that everything is fine, we're going to return the OK here, and we're going to define our error type here. The first error will just be cannot start. So for that, we're going to derive the this error, colon, error. So that is actually an updated technique here that I'm using. It's much simpler. We don't have to have a use above, and it avoids naming conflict here with below. And then we have obviously the debug. And within the enum error, we're going to have a fair start web folder not found. So in case the web folder doesn't exist, and that will take a string. And in this error, the way that gets outputted when we print is with this error message here. And we are doing this positional display of the value. Now we need to import the type. So on this one, arc, that is an easy one. Now on the database, we do not have actually exported this object here. So if we go to DB, we see that that is a type, which is that DB is public, but is not exported. So we could do a kind of model DB and so on. Here, that will be a pub mob DB, but it's actually, I like to re-export, and that is just a personal preference. So use whatever makes sense for you or for your team. I like to do a pub use DB. And so that will re-export the DB type in this case from the module model. So if I press save here, I'm going to go back. And now if I do a command dot, I should see it model.db. And now we should be fine when I press save. So everything compiles, doesn't do anything because we're not even calling the function, but that is already a good start. I'm going to stop the test here because we don't need a cargo watch at this time. Okay, so the first thing that we're going to do is validate the web folder to make sure that it's a valid one. So very simple, we're going to do if the path does not exist. So here I'm creating the web folder and I'm calling exist, will return early. So we do an error, and that is the error that we have created below. And the string will be the web folder to string. That will make sure that if we pass a wrong folder, it will complain. Make sure to import the path. The next step is to create the static content filter or router. And the way you do that with Warp is relatively easy. You create a filter, we are going to call it content and warp fs dir for directory, and you give your directory folder. And that will take care of serving the files, the static files, when they match the path. Now, it's not going to take the root and match it to index.html. That is what we're going to add right now. So we're going to say root index, and we're going to say that in warp, we say when it's a get, and the warp path end, which means that is basically localhost or your website, the port, and slash. Then we're going to add the filter, which is going to be a warp fs file. And here we're going to do something that only works on Mac and Linux, I guess. You can easily use path or something to make it portable. Index.html. And we're going to give the web folder here. So that basically will say that when it's the slash, the root, it will map to this file. And then just to be clean, we're going to map these two guys on a static site filter. And the way you combine that is with content or root index. And then below, that is going to be just a placeholder for now. We could just have the static site, but later we'll have API above. So we're going to say combine all routes, and we're going to say let routes. And for now, we're just going to move this variable to it. Later, we will compose as well. And then finally, we're going to do a println, start the server, and we're going to put the port here, and the web folder, so that we know what we're doing. And here we're going to put web port, web folder. And the way you start it with warp serve, the routes that we have, and then we run, and that takes a tuple with the IP address as an array and the port. And then that will be async, so we make sure to put the await. Press save, and everything should work, except that here, to have this composition of warp, you need to import the warp filter. So that is the way that Rust works when you want to add method from a trait implementation. Okay, so now that we have that, it's time to update our main function to make sure that we are calling the warp router. So first we're going to make the main function async, and we're going to use Tokyo for that. Tokyo is our async executor. And then obviously here, I need to put async. Then the third thing that we're going to do, compute the web folder. And that is simple, but it's important, such as when we are in development, we can do relative paths to the web folder. And then in production, you can put the web folder just next to the executable. So we're going to create two constants, the default web folder, which is going to be web folder. So that will be by default, has to be next to the executable, but we're going to allow to override that with the command line, and the default port for now will be hard-coded to 8080. So now when we compute the web folder, first we're going to take the argument from the command line. So we're going to do this way. Eventually, you could use something like clap or something like that. In this case, we're going to make it very simple. And then we're going to say that the web folder is either with last argument, and we're going to do an unwrap or else, and then we'll do a default web folder to string. So by default, it will be the web folder, but in the command line, we can pass a specific path. And just for symmetry, we're going to have the let web port equal default web port. And eventually that could also come from the arguments. We need to include the env in the import. Now what we want to do is get the database, such as we can pass it to our web start. And to do that, we're just going to use our initDB. And for now, we're going to fail it cannot make a connection. But in a production environment, or even later in development, what you want to do is loop until validDB. Because sometime when you deploy your web server, the database might not be active or variable, and you want to make sure that it can reconnect and so on. And even when it started, that it can retry for a while. And then here we're going to create our arc, such as we can pass it to everybody. Now the trick is that initDB, again, if we do a command dot, is not available. And the reason is same thing as before, is that it's not exported here. It's part of the module, it's pub, but it's not exported. So what you want to do here is a pub use db initDB. Like this, my structure is more flat and I can cherry pick what I want to export. It's not too dogmatic. Sometimes I can pub a whole module, but usually I prefer to do it like that. So now if I go back to the main and I do a command dot, I should see it here, click import. And now the final step is going to start the server. And that's actually pretty simple. Start web. We're going to give our web folder, our web port, and our DB. We're going to do a wait. And here we are doing a match, such as if it ends with void, anything, we don't really care. We're going to do a println, server ended. And there's a case where you want to end, like for example, again, if you deploy in Kubernetes, you might want to listen to event and doing a graceful end. That could be very useful. And then obviously if we have an error that cannot start or anything, then we are going to println web server failed to start cause, and right now we're going to do the debug, and that would be the exception. Press save. Everything should compile nicely. Okay, so let's close the files and let's open our README. And we are going to add another section, which is going to be our dev web. And that is going to be a cargo watch, the same technique here. But now we are going to run the program. It's not going to be the test. And we are going to pass the web folder relative path to our frontend. This is why it was useful to be able to customize that as a command line level. So now if I copy paste this one, put it here, press enter, seems to be started nicely on the web folder, so the web folder exists. Now if I pop up a browser, I do localhost 8080, press enter, I get our hello from todoMVC. So far so good. Okay, so this is great. And we're going to come back to our test-driven development here. So what we have is the first one that is a test for the model. And then we're going to have a similar command line. And we'll just put it here because it's easy to copy paste. And that will be our test for web. So exactly the same thing, but with the web here. So we're going to stop this. We're not ready to run it yet because we haven't written the test yet. Also for later, there's one thing that I like to do when I do the test. I like to use this error for the code, but for testing, I like to have a dev dependencies of anyhow. So that makes it more flexible, less structured. So that's why that in the code, I like to be very structured, but in my unit test code, I'm fine with anyhow because it gives us the flexibility that is needed. Again, this is a personal approach. You can have your own. As long as it sounds, it's great. Okay, so now we are ready to implement our first to-do, the web layer. And for that, we're going to go to our web layer and we're going to include our to-do web module. We're creating the file todo.rs. And the way we're going to design our code is to have one function that will return all of the filters, the composition of filters for this module, for the to-do. And then if we have projects or users, we'll have one for each. So we're going to call it to-do rest filters, and it will take a base path. And that is a flexibility that can become very handy later. And for now, we're going to make sure that that is static to the code. And we're going to have our DB, and that will be our arc, because it will have to be cloned. And that will return an implementation of the warp filter, which will extract implementation of warp, reply, and then the error will be warp rejection. And we'll see later here what that means. But for now, this is a boilerplate code. Press save. So we're going to import the arc, import the DB, and then we're going to import the filter. And then obviously we get this error because we didn't return anything yet. So the way that warp works is that you compose your filters and you can have custom filters that extract some data, such as it can give it to your router function. And we're going to see how it works. But first, we are going to create a couple custom filters, utilities, that we are going to use in our to-do REST filters. So for example, let's create a code section for our filter utils, and we will move it to some other places later. So we have the with DB, which is just going to do a clone of the DB arc. So that will allow us to include the database into our filter router. And then the second one that we're going to do, and is going to be a very basic implementation of it, and is going to be our do auth, which is going to be for authentication. And that will return our user context. And that is a way that we can call an async handler as a closure. So Rust doesn't support yet async closure in a stable version, but you can have a closure that has an async block. So that is what we are doing. And here we are making sure that we are giving the type information to Rust, and we are returning from our previous episode the user CTX from a simple string here. And that could be a JWT or your token strategy, whatever you want. And for now, we're going to have an unwrap right now, and then later we can see how we can have a proper error handling. So now we need to do some couple import. And now we are all set up to do our first implementation here on the to-do REST. And it's going to become more clear how we are going to use these custom filters. And so the first thing that we're going to do in our custom filter is that we're going to build the common filters that will be used through our route. So the first one will be the to-do path. And that will be the warp path. And that will take our base path. That could be API, for example. And then we are going to compose it with another path part, which will be to-dos. And that will make sure that, for example, if the base path is API, everything will be API/todos, and then we have the get, the post, the delete, and all of that. So that will make everything very consistent. We don't have to duplicate code. The next common filter here that we're going to use is going to be the composition of the with DB that we created below. And we're going to give the DB clone here. And that will allow us, each of our router will have a copy of the DB reference. And then we're going to compose it with our do auth, the one that we have just below. And we're going to give again the clone. In this episode, we're not going to implement a full authentication, but we know that eventually you want to have database access from your authentication. So now that we have done this setup, we're ready here to create our first route. And that will be our list for to-dos, and that will be a get to-dos. We're going to call it list. We're going to create our filter. So we're going to do a to-do path. We're going to compose it, and we're going to say where it has to be a get. That is the way the REST works. And then we're going to say if the path end, because if there's something else, then it's going to be a get of one entity. So that is the way the list works. And then we're going to have another end. And this is where we're going to add our common filter that we're going to clone. Because later we're going to have more than one route. So we want to make sure that everybody has their own copy. And then we're going to give the filter extractor in a way, the one which is a route, the end function that does a job and return the result. And that we're going to follow this convention here, which is going to be to-do list. And then for now, that could be the only thing we return. Later, we'll have more with all of the CRUD REST API. So we're going to press save. And now the only error that we have is this one because we haven't created, but we are returning the appropriate type. Okay, so now we can create our route handler. And that will be a async method. We're going to call it to-do list. And because the common extracts the DB clone and extract the UTX, the two first parameters will be in this order. So we're going to have a DB and the UTX, which is the user context. And so far, the user context, as we have seen in the previous episode, just have the user ID, that's it. And it's hard-coded. So we can see the hard-coding here, and later it will come from the token. And the way that warp works is when you want to extract data, you return a result. So that will be of JSON type, and then the warp rejection. And we're going to see how we're going to handle these two later. So the first things we're going to do is we're going to get our to-dos. And that is where it's very simple now, because we have our to-do Mac that we created before. Just do a list, and we give a reference of DB and a reference of UTX. And the to-do Mac will do all of the other magic. And for now, we're going to do a wait, and something very bad, we're going to do an unwrap. Just for now. Later, we're going to fix that and we handle it correctly. So we're going to make a note here. The to-do Mac needs to be imported as well. So we're going to follow our strategy here. And we're going to pub use to-do Mac. Again, if you don't really like this strategy, you can do a pub mod to-do and everything will be exported this way. And so now if I go here, command dot, I can see my model to-do Mac. And now that we have the to-dos, we're going to get our response. And the way it works here is we're going to format it in JSON. And our convention, just a convention that we're following, can be anything you want. We're going to always put the data in a data property. And that will be our to-dos. And these are to-dos here. If we toggle the Rust analyzer type inlays, they are vector of to-dos. So it will get formatted correctly. And we might have to add some CRD.json macros to the to-do type. We'll do that later. And then we do a OK. And we need to make sure that we wrap it into a warp reply. Couple of things. So this one needs to be imported. It's not SQLX, it's warp. And then this one should be the CRD one. And if I press save, it might complain because the to-do object might not have the right type. So to do that, we go back to our model to-do. And here is the to-do types. And I'm going to add here serialize. And we need to make sure that there's a to-do status here. So we need to make sure that the to-do status enum also have a serialize. I'm going to press save on this one. And now everything compiles nicely. Okay, so now that we have that, we want to create our test. So for that, let's close all of our thing here, and we're going to follow the convention we have, which is having our test code section. And then we're going to add our path here, which doesn't exist yet. And we're going to create that under our test folder, web-todo.rs. And now on the test web-todo, we're going to create our Tokyo test, and we're going to follow our naming convention, web-todo list, that will return a result of void. And the result, rather to use the default result, we're going to use the anyhow result. And that will allow us later to put context and so on. We can actually go back to the README, copy paste that here, and obviously everything should pass. So now we're in business. So we're going to create our fixture. And that basically is what doesn't change during the test. And that will be the DB, wait, has to be an arc. And the reason why we're using that is because we're going to use a warp unit test kind of feature, such as we can ingest our to-do APIs. And the way we do that is we have our to-do APIs equal to-do rest, and the base path will be API, and the DB will be the arc. And as a best practice, we're going to do the clone. We don't need it actually in this test, but in some other test, we're going to use the DB later. So this way, it doesn't really matter from a performance standpoint, and it makes everything very symmetrical. And then on the action side, the way that in warp, you can unit test your API, you do a warp test request. The method will be a get. So here we're building our HTTP method in a way. That will be API to-dos. And then the way we pass our filter is like this way, with reply, and then we're going to await. And then we can do a very basic check for now, just making sure that the status code is 200. And if we press save, hopefully everything should work. Probably forgot some import. Press save again, Now our test should compile. So now what we want to do is to test the response data as well, obviously. And to do that, we're going to create a little helper function. We're going to call it a web test utils section. And the function will be about extracting the body data from the response. And so that is what we get from the warp test here. So what we want is to deserialize that. We need to make sure that the result will be a type that can be deserialized. So that is a way that we're typing it. And the lifetime just matters for this variable. It's not something on the function. So this is how you can do this higher rank lifetime. And then the first thing that we're going to do is we're going to parse the body. So we're going to get the body from the response. We're going to parse it as UTF-8. We're going to throw an error here. So we're using anyhow. So everything will cascade up nicely. And then once we have the body, which is a string, we're going to use Serde to have it as a JSON. And if there is an error, we're going to throw this. Then we're going to extract the data. So that's why we have it as mute here. So we're just taking the data and then we deserialize it. So this is the reason why we need to make sure that the type that this function will be bound to is deserializable by JSON. That is what happened here. So in this case, we don't really need to have a function per type. That is part of the monomorphization of Rust, which will create a function per type that is required. And then finally, we just return the OK data. There's some few functions here that needs to be imported. We need to make sure that we import all of those. And then the with context here needs to have the anyhow trait. It should almost work. So the from Serde and the value from Serde as well. And then finally we have this one. Okay, everything works. And obviously we haven't used the function yet. So the way we do it, go back here to our check. We're going to use our function to extract the body data as a vector of to do. And then we can do our additional check for our to-dos. And very simple. First, we're going to check that the to-do length is 2. So that is our seed. Then we're going to make sure that the first one is a 101. So we have, and because it's reverse order, that will be the first one on the list. And then we're going to make sure that the title match as well. And we know that the second one is open. So we're going to also check the status. We're going to press save. We need to make sure that these types here are exported from the model. So we're going to go back here and we're going to make sure that we export to do patch, to do status. And now if I go back here, I should be able to import the model and import that from the model. And then the issue that we have here is we don't have the deserialize. So we need to go back to the type and make sure that in our data type, we have the deserialize from Serde. We're going to do that. And we're going to add it here as well. We're going to need it later. Save. Everything should compile nicely. And now the whole test works. So that's pretty cool. So now we can do some cleanup. So now we can refactor our to-do and we're going to put the filter utils in the on file. So the do auth filter and drop it here. And then this one, and we're dropping that into the filter util. And then that's it. We can remove that. Okay, that is not part of VS Code. It's a little bit of video editing here to make it cooler. Press save, and then everything should work nicely. Okay, so there's a couple of things here that we need to fix. The first one is this one. In our code, we should never have unwrap, or in a very rare cases, or when we are very sure that it cannot fail, because we don't want the panic and the whole web server to go down. That has to be fixed. And then we have the same one in auth, where we have the unwrap here. So to do that, Warp has error handling. So if we go back to the module, the way that Warp work with errors is with the concept of custom message. And so the way it works here, and we're going to put everything in a code section, is the first thing you do is you do a struct, which is your error message. So we're going to call it error message. can have the data you want. So we're going to have the type of the error message, and the message. Eventually, when you do production, it can become more advanced, but for now, we're going to focus on that. Then you need to implement the warp reject for this message. And then what you need to do is to implement the rejection to make sure that you are going to create a warp reject custom with this message. That is the way it works. It's a little bit of boilerplate, but then after it works very nicely. And then for each error type you have, you are going to add an implementation of from. And so here we have this error of the module web error. And we are going to create the custom message, the rejection, with this tip, and then with the format. And then we can do the same thing for the model error. And then you can do the same thing for security error. And now, with this boilerplate code, you can go back to your to-do and resort to have the unwrap, the magic question mark, press save, everything works nicely. And then you can do the same thing in the filter auth, and resort to put unwrap. Here you put question mark, press save, and then everything works nicely. And you can handle your response the way you want. Okay, so now is a good time to refactor the do auth filter. So here we are hard coding the value of the token, and that should obviously come from the header. So we are going to stop cargo watch because we are going to do quite a bit of refactoring. We are going to create our const for the HTTP header that we'll be using. So X-Auth-Token. And now we're going to rewrite our filter. So it's going to be relatively simple. We're going to have our warp any to make sure that that can be applied to any filter. We're going to extract our DB, and we're going to remove the underscore because now we're going to use it. And that will allow us to have the database. And then we're going to extract our token, and we're going to use the warp header optional. And that will be our header X-Auth that we created above. We could have done header, but that will have thrown an exception if it's not present. So we want to make sure that we handle it our way. And then we're going to have our handler, which is going to extract the data, the user's CTX. And the way you do that, because we want it to be async, it's going to be a and then. It's going to take two arguments, the database that we extracted above, and that is our argdb. And then our X-Auth, which is our option string that gets extracted from the header. We want the block to be async, so we're going to add async. And because that is a code block, it's not an async closure, which is not supported yet in Rust, now we need to move those arguments into the block. That is what is happening here. Now we are going to do a match on the X-Auth, the optional string. When there is an X-Auth, what we're going to do is create our UTX, and we're going to use our UTX from, and we're going to do a reference of X-Auth, which is our string. And now we're going to return the value. And for that, we're going to return OK. And here's a trick, because we're in an async block, we need to give a little bit more type to Rust, such as it can wire everything up, and we don't get an error. And here we're using the turbofish notation to say that the type of this OK will be user, CTX, rejection, and then we're going to give our UTX. And now, if we don't have any authentication, we want to throw our own error, which will be error fair auth missing X-Auth, for example. We're going to make sure that we're casting it to the right thing. And now we need to create this variant that we just created. So we go to the mod.rs from the web, and we're going to add that here, like that. And with our error message here, that will tell us what's happening. So now if we go back to our filter auth.rs, we're going to make sure that we import our create web error, and we need to make sure that we're importing this. And then here, thanks to Rust, the UTX from token is async. So we need to do a wait. And before we handle the exception correctly with security, so we can do a question mark here. We can remove our previous line, and then that's it. There's one more refactoring we can do. And that is making sure that our UTX from token actually takes the database. Right now it doesn't, it just takes the token. But it will need the database to make sure that the user exists, or even to get some user information to verify the signature. So what we need to do is we are going to go to the UTX from token, and we're going to make underscore because right now we're not going to use it, but it will take a reference of DB, making sure that we import the DB. And now if we press save, that will complain a lot, obviously. It's going to be relatively quick to fix. We go back here. Now we can pass our DB reference, press save. And so the DB is an arc here, but it has a as ref, so automatically it will cast to the right thing. And now in our test model that we did in the previous episode, we didn't give the DB. So we need to add that to everybody. So we're going to use VS Code things, Command-Shift-L, and then because everything is very well normalized, we do this, press save, and that's it. Now we can close this file. We're not going to use it. So now if we run our test, we're going to get our error because we didn't give in our to-do list the header. So we're going to copy that and we're going to go to our web to-do test. And here, which is our web to-do list, when we do our action, we need to add header. That will be our header and the value will be 123, for example. Press save and then that's it. And obviously here we have a very early kind of token scheme. You wouldn't have that. You will have something like the user ID, the user info if you want to follow the JWT format, and then you will have the signature probably in a base 64. So then after you can have any kind of scheme you want and use any library you want inside your function, but that is basically the infrastructure to do token header authentication. Now there's one thing that we're not doing that we should be doing, and that is the recovery of a request. So in this case, when it fails, we don't see any error message. And the user just gets the default kind of bad request. So for example, if we comment this one out again, press save, we get our failed, but we have no clue of what's happening. Yeah? So that is a fail of the unit test, but there's nothing before that that is printing in a log or anything else what really the error was. And in fact, if you get the request, you would get just a 500 and then that's it. So in Warp, you handle this case with recover. So first here, let's cross some files, such as we can see a little better what we have. And now we're going to go to our web module, mod.rs, which is basically the root of the web module. And we're going to add a function here just after our start web, which is going to be async. And that will be our handle rejection, which will pass to our recover of the filter. And we'll see that later. And that will take the error, which is rejection. So that is a warp construct. And that will return a reply that can be sent back to the client. So every time we have an error, it will break the things and it will reply. And obviously here, this one shouldn't fail. So we're going to put it infallible, which is a convention to say, well, this function should never fail. So now we're going to follow a couple of best practices. The first one we're going to do is print to server side, which means that we're just going to use a println and we're going to simply print the error log like this. And that will allow us, when we deploy these services within a Kubernetes or Docker, to just being able to see what is happening on the console. And that doesn't have any memory impact because it gets erased eventually. And so that is a very convenient here to print things in the console. Obviously later you can have more sophisticated way of deciding what you want to print or not, but that at the beginning will give a lot of mileage. Then eventually in your code, you are going to have to call your log API for capture and store. And so that will probably be more structured. We'll need to have some sort of, request context actually, but then eventually you will be able to store the logs, capture it, put it in S3 for further processing later. And we're not going to do that today. You can start your application quite a bit without doing that. And then finally, we're going to build our user message. And the goal here is you send to the user only what the user needs to know. And so you log everything you can, except password, obviously, on the server side, and then you trim the version that you're sending to the client. So we're going to do a silly example here, which is our user message. We'll do a match on the error. So that is a rejection object. And there's a method here in Warp, which is called find, which will find an error message type. And so the way you give a type in a way to a function is you use a turbofish. That is a nice pattern of Rust. And you do error message. So that is what we created here. That is our Warp error message. So now when we have an error message. For now, we're just going to return the tip. And then obviously in your code, you can return much more. And then here we're going to return unknown, such as we always have a user message. And now we can format our error message to JSON. We're going to format it using the JSON CAD macro as a JSON object. We're going to warp it into a reply of warp. And then finally, we're going to return with a status. So we're going to use a warp reply. We do the status, we give our result, which is a JSON. And then we're giving our warp status here, which is going to be bad request. Now, if we press save, there's going to be some import to do. Our test is still failing, obviously, because we did not provide the header before. But now we can use this handle rejection that when we start the web, at the end of the route, so when we combine all the routes, we're going to do recover and the rejection. So that is when we start the web server. We need to add this recover handle rejection is in our test as well. So if we go to our web to do test, we're going to add the recover. Make sure we import this function. We need to import also the warp filter that is part of the filter trait. Press save. We still fail, but now if we go back to our failure above it, hopefully we have our error in the console, which will be the same thing when we run the server. So that is a big thing already. So make sure you take time to do that early on, such as you can quickly debug your web server. So now obviously we want the test to pass. So we're going to uncomment this line, press save, and everything works very nicely. So our test works, we recover the error, and we print the error on the server with all the information. So now that we have that working, we can continue to do our web REST API. So let's go to our to-do web, and it's going to be pretty quick actually. So first, we're going to put this code here, which is formatting the response. That can go to a function, a JSON response, and then we put the code that we had before, and that is obviously data. And this will basically be monomorphed every time we pass a new data, another type. The Rust compiler will create another method for the specific type. So the Rust compiler will do the work for us. And now here, we just need to do a JSON response, and we give our objects. Just need to do this import. So now let's go and add all of the REST APIs. So the first one is going to be the to-do get. And in the get, we take the database, always the same signature here at the start, the user context, and then the ID, which will be a I64. And then in this case, is a to-do object, and that will call our to-do MAC, model access controller, with the DB, the UTX, and then the ID. We have our question mark, which everything works because we wired it up with a warp error, and then we call our JSON to do. Then we have our create, and so the create is going to be a little bit different, but again, the same signature start, DB and UTX, and then we have our patch, which is going to be what is going to be parsed, and we're going to see how we wire that up in our filter above, but that basically will be our to-do patch, and then we just call the create with a to-do patch because it expects a to-do patch. We need to make sure that we import the patch here. And then again, all of that is not wired yet to our warp filters. We're going to do that later. The next one is the update. So here again, to do update, our DB, our UTX. And then an update, we're going to decide that it takes an ID, which is going to be the ID of the item to be updated, and the to-do batch, which has an optional of title and an optional of status. And then we call our to-do from our model access controller, and then we just pass those arguments. And finally, we're going to do the delete. And in the delete, we're just going to take the ID. And we're calling our model access controller with delete, and it has the same signature. So everything is very consistent here. Press save, everything should be fine. And now we can go on top to see how we're going to wire all of these handles. So let's add our get filter. So it's going to be a get and to do and slash under the to do ID. So for that, we're going to have our let get the to do path. So that is a path that we have above with the default path. Then we're going to say that needs to be a get. we are going to clone all of the common filters that we have here to make sure that we have the DB and the auth, because all our APIs will be normalized. And then, so that will pass the path param, which is the next element after the first todos. So the first one, that is what we are matching here. And then the second one, that is what it will extract, and then we'll give it to our warp handler. And then we just wire this filter to the to-do get that we just wrote before. So now we can do our create REST API. So for the create, that will be a post to our to-dos with our body to-do patch. Starting with our to-do path base filter, we're going to say it needs to be a post. And then we're going to clone our common filters for everybody, such as we have the same two arguments, the DB and the UTX. And then we're going to ask warp to parse the body as a JSON. And then after we are passing this result into our request handler. And because we are passing this result here of the JSON body to the to-do create, and our to-do create has a to-do patch as a signature, then Rust will do the right things and the right deserialization will happen. So very similar, we are going to do update, and that will be a HTTP patch, the to-dos 100, and then with the body as a to-do patch. We do the to-do path. We're going to say that that is going to be a HTTP patch. We're going to use the command clone again. We're going to get the first param path here, so this value, and then we're also going to parse the body. And here we could be a little bit more advanced, where we could put a constraint on the size of the body. But right now we're doing the simple way. And then again, we're going to create our to-do update. So the to-do update will have 4 arguments. The 2 from the clones, which is the DB and the UTX, plus the ID, plus the body, the to-do patch. And that is what we have done just before. The last one will be the delete. So it will be a delete to-do with our ID as a path fragment. So the same delete, make sure that is a HTTP delete. We're going to clone our command. We're going to extract this path from the parameter of the URL. And then we're going to give it to our to-do delete. Press save, and everything should compile nicely. So now the only thing that is remaining to do is to compose all of these filters together. And the way it works with warp is we do a or get, or create, or update, and or delete. Press save, everything should compile nicely. And obviously right now we only have one test, and we're going to fix that right now. So if we go to our web to do test, so we're going to add our test for get. So very simple, we're going to do a web to do get OK. And the first things we are going to do is create our fixture, which is going to be our database, like in the to-do list test, and then our to-do APIs, and we add as well our recover here. Now the action of the test is going to be a get with our auth-token here 123, and we are going to query the API to-dos 100 that we know that exist in our mock database. Then we are doing our check status here, and then we extract the body and we parse it into a to-do. And finally, we are going to check our data, and that we are making sure that is 100, that the title is 100, and then that the status that we know, because we created the mock data in the SQL, that is closed. If we press save, now we should get 2 tests, and now it should be working. Now let's close this one, so as we can get organized. And then the second test we're going to create is going for the create. So very similar, we're going to do our web to do create OK. So again, we're testing the happy path. You want to test the failure path, obviously. In the fixture, we're going to create our database. We're creating our to-do REST filters here, the same as everything else. We could put this code in some utility function probably. And then as a data fixture, we're going to create our body JSON with a test title. In our action, we're going to do a post. We're giving our token. The API will be API to-dos. We're giving the body, and we are calling it with the to-do APIs filters above. We're going to check the status to make sure it's 200. We extract the data, and then we do the check. Very basic, this one. We're just going to make sure that the ID is above 1000, and then we're going to check our title and our status. And that is a default. We didn't set it in the JSON body, but this is a default which is set at the database level. We probably are missing one import somewhere, and that is a JSON from service that we haven't used so far. Press save, and now we have those 3 tests. Okay, so if we go back up, we're going to close this. So to test the update, very similar. We're going to have our web to-do test update, our fixtures with our database and the to-do APIs. Then we're going to create our fixture body for the update. We're going to have our title and the status will be open. In the action, we're going to make sure that this is a patch, our token, and the APIs. And then we give our body, obviously, because that is a patch, it's an update. And then we execute it with the filters that we have created above. We check the status, that is 200. We extract the data. And then we are going to assert that the ID is still 100, the title, and the to-do status that is still open. Press save. Now we should have our for test, and everything should work fine. Let's go back on top, close this one. And finally the delete. So very similar again. We have our fixture. Then for our action, we're just going to do a method, which is delete on to-do 100. We're going to check the status. We're going to extract the data because in our API, we're actually returning the deleted to-do. We're going to check the to-do, making sure that the ID is 100. We're going to check the title and the status. So the status of the 100 is closed. This is what we had in our database. And then we're going to do an additional check to make sure that there's only one to-do now in our database. And so for that, we're going to use our UTX from token. We're going to do a to-do MAC list. So here we're going to use a to-do MAC. And then we're going to make sure that we only have one to-do in the list. And the to-do that we have is a 101. So we're going to have to import this because we haven't used it so far. And import the to-do MAC as well. Press save. And now we are running our 5 tests. So obviously you will do more tests to test the failure path as well. But this is the gist of it. So now we have our test that works. What we want to make sure is that the REST APIs for our to-do is wired to our web server. To do that, we're going to go to our web, the module. We have our start web, which is what is called from main to start the web server. Now what we're going to do is create our API filters. And we're going to say that the APIs is our to-do REST filters with the path API and the DB, which is the ArcDB that we have here. And now the way we compose the APIs with the route is APIs or, and we do a or static site. So first it will go through the APIs, and if nothing match, it will go to the static website. Press save. Everything should compile. We pop up a browser. We do the localhost 8080/ that will do our hello from todoMVC. And now if we do a API to-dos, press enter, and we have our error message, which is basically because we don't have the X-Auth header, which proves that everything works nicely. And on the server side, we have all the information that we need, which is that the method is not allowed, and then eventually we have the missing X-Auth-Token. So we're going to do the web UI in the next episode. For now, just to make sure that we can show the first JSON, what we can do, we can hack our own code. We go to our filter auth, and here rather to have this kind of match, we're going to do a brute force, which is if it match anything, and we're going to hard code it 1, 2, 3. So obviously this is redundant, it doesn't really make sense, but just to make sure that we can see the result. Press save, and then if we pop up the browser back, Command R, and that's it. We have our data JSON. So obviously we don't want that. So we're going to go back to the right way. We'll recompile, go back to the web browser, Command R, and then we get our error. And then obviously later, everything will be loaded from the root, and that will use a JavaScript that will add a header, and then we'll be able to see the REST API working. And that's it for this episode. In the next episode, we're going to do the front end. Until next one, happy coding.